So let me restate what I just said. So your assignment basically is the tutorial here. You are again looking at Unreal documentation for 5.6. The code that you're seeing here is more akin to early 4. I'll be quite honest. It's more akin to how you would build things in Unreal Engine 3, 3.5, more akin to early Unreal Engine 4. And I'll explain that in one moment. And that's one of the things that if you're looking at any of these particular documentation from Epic, this is something that all these programming tutorials right here, they're all going to be out of date. That the way that you would build this isn't the way that you would build. The way that they're showing you how to build this with these tutorials isn't how you would actually build it today with Unreal Engine 5. And the way we know this is that we can go look at the examples given to us. The prototype examples given to us, the first person shooter, the third person shooter, the top down, they're all built differently than from how these tutorials are showing. And again, what's going on is that the history lesson is basically that when we go further back in time, you were doing more in your C++ classes. You're doing a lot more in your C++ classes, and part of it is you'd be setting up objects and things in your C++ classes. Whereas now that's been pushed over to essentially the blueprint class itself. And that's something that we'll look at that. We'll ask, how should we build what we're building? It is going to tell you to create a new project. You don't need to make a new project, so don't keep working with the project that you have, basically. So you could skip all this required setup stuff. Make sure that you do go into your content draw, right click, add feature content from pack, go over to content, and make sure you add the starter content. Please do this. You want these materials. Now, I've already added them to the project, so that's why I'm not going to click add to project. If you look at, there is level prototyping, starter content. So here is the stuff that package brings. So, and I'm suggesting you do that because mostly for the materials and all these wonderful materials, particularly these, the rust, the gold, the copper. I'm using copper, gold, rust, and one other. I think it is maybe steel. No, I'm only using rust, copper, gold. So let's get back to the documentation. So it's going to ask you to create a new class. You are going to create, and this is the older Unreal Engine 4 layout, but you are using an actor class. So the C++ class that you're going to create is an actor class, and the other way that we will set this up. Now in my project, if you go here, the code that you see here, I've got. Let me go through my C++ classes now. I've got a floating actor, and I've got the floating actor old school. So the old school is the one that is directly in code, as the tutorial is going to show you. Floating actor is the second way I thought about doing it. And I will actually suggest probably taking this in another direction altogether. There's a third way that I realized today that I'll probably show you how to set this up. So the first way is the floating actor old school. And so what they're doing right here is basically they're like, hey, go create the floating actor class. And in 5, it's under tools, new C++ class. There is, you can go in here, create a new C++ in this folder. You can right click and do new C classes here as well. If you do it here, then it will actually create the class in this folder. We'll actually create the third way now that I've realized it. But let's go back. So they say edit the class, open up the .h file. So if we go back, we click on old school actor. Visual Studio should open up both the .h and the .cpp. So here is the old school, and let's get rid of the configuration. So here's the old school .cpp, and here's the old school .h. All right. The thing that we are adding to what they're going to show you, the first thing is they're going to, hey, U property, visual anyway, use static component, visual mesh. So it can be seen anywhere, but not necessarily adjusted everywhere. They have a begin play and they have a tick, and this is the default. This is the constructor. Thought of this on the way in today. The best way, again, begin play, start. For those of you who are more used to Unity, this is equivalent to the Unity start. This is equivalent to the Unity update. This is the equivalent to the Unity, for our purpose, what you would do in Awake, effectively in the script. So now that's not technically there's where you would write the similar code. All right, and this is going to be very evident very quickly. So now that we've let me go back. Now that we've added the static mesh, again, use static mesh component is where all static mesh components are going to be. And we created a variable visual mesh. So first thing in .cpp, here is the constructor. First thing that you'll see that we have a function called create default subobject, the type, what we would want to call it in the editor, which in the example given is mesh. And the first thing that they do with this is that they tell the visual mesh, they use a setup attachment. Again, this is the pointer, and we're looking at the root component. And this is a variable set up within the actor itself. Defines the transform of all other components must be all other components must be attached to this one somehow. So you could attach multiple things to the root component, and they would be technically the root. It's one of those you wouldn't want to, actually, and we'll talk about that in one moment. Let's jump back to the code that they're giving you, and that's, again, this is the code they're given. Here is them creating the component and attaching it to be the root. Then I'll just show the code here. That should make more sense here. So they've got this constructor helpers, f object helper of type use static mesh. Q visual asset is the name of what we're trying to get. And then they throw it into text, and it's this game starter content shapes cube. Again, this is why the starter content is important, because we're actually using it. All right. So what they're actually, let's go jump into Unreal for one moment. Let's go find that. Here is shapes, shape cube. And let me just grab, where is it? I think I want to, yeah. So you want to copy the object path. That's what they're using right here. We can look at the file path. There's a couple other different paths here, but we'll copy the object path. We'll jump back in, and I'll just paste this in. And here is game starter content shapes shapecube.shapecube. And this is how Unreal builds their stuff. But that's what's inside this right in here. go in, we can build the string. Just again, for your purposes, take out these spaces because it's going to look at that as think of them as different tokens as opposed to this one big string. We will go in and I'll build the next version when I so what they're doing here is they're basically finding the object and then they ask if you seeded to build get that object, the static mesh is being set static mesh to that object, and then we're setting the relative location. We needed to set it 50 by 50 by 0. In the code, this is one of the weird things that's going on. They're setting the relative location to 0, 0, 0. I'm gonna I'll go back and let me see if I set this back to 0, 0, 0. This might cause a problem. Okay, so I'm gonna remove the actor old school, and then I'm gonna go back in to my C++ classes. I'm gonna put the old school floating actor in, and I think I don't think. Press play. It's not doing what I wanted. I think that was actually the one that was okay. We'll come back to that. But essentially, it's setting its relative location. In this case, under tick, basically, they're not doing it in begin play, but they're getting the location rotation. They're doing. I don't fully understand why they're doing this. I'm not sure why it's just not math plus delta time. Oh no, they need to do, yeah. I see what they're doing. They're adding the running time plus the delta time. So running time is get game time since creation. I'm not sure why. This is one of those I might not even bother to do that. They're subtracting the running time to get the correct, yeah. The difference between the sign here and the sign there, I might actually just leave it like this. But hey, this is what they're doing. This gives us a new location. So location z is equal to delta height times 20. We're adding that. We will come back. One of the things we'll come back at the end of that they say create a variable for this, create a variable for this 20. Delta rotation is delta time times 20, and then they add that to the yaw. And then they use set actor location rotation, new location, new rotation. We'll come back to this. We'll take a look at what that would look like in Blueprint as it's written this way. You'll be surprised. But that's pretty much what the new school actor is doing. It's basically getting its location, figure out what the delta is on getting the current time, figuring out the height, figuring out the new rotation, setting those to the variable, and then setting it back to the actor. Pretty much straightforward what you've done so far. This code right here is not going to change pretty much at all, actually, I should say. Between this and we go back to floating actor to CPP. I mean, it's the same. It's going to be the same code. When I do this the third time, this code's not going to change again as well. But how we approach it is going to change. All right. So for reference, I made a floating actor in Blueprint. And one of the things I did is I basically made an event, the event tick goes to a function called update cube. And the reason I did this is because we are using local variables in our C++ code. We don't have local variables here in the event graph. We get them inside functions. So I basically simulated that we're actually inside a function. We go up to update cube, and like the first, and I've used a sequencer to help break this down. First thing is I set delta time, which is this delta time variable is getting a local variable of that name. I get the actor location, set new location, new rotation is set to there, running time is set to that variable. So basically, if we look at the code one more time, this is what those first 4 lines. I set a variable for delta time, and then I've set these up. Next, I did delta time, running times through sine. Running time through sine, I subtract it, and then I set that to do the delta height. Actually, should be doing a little bit more, but I multiply that by 20. And then I break the new location, again, the variable for new location. I'm basically dragging get, and I'm basically splitting the struct pin. I'm using this twice because here I'm adding the z to here, and then I'm using the x and y to set those to these values right here. And then this is on the other side. This is new location set. And again, I'm using split struct pin to get, so basically I'm keeping the x and y as it should be and setting the z as it by the new delta. So pretty straightforward. I'm doing the same thing over here in this case. So grab delta time. There we go. So here is 2 is doing setting the new rotation. So delta time times 20. I'm getting, again, setting the z variable on this, keeping the x and y, getting the new z. Huzzah. And then the last one is basically taking the new rotation, plopping it into set actor location rotation. And for our purposes, all of this blueprint right here is equivalent to this code right here. So there is times where blueprint is more beneficial, and there's times where it's not. And I just showed you that basically I've had to write the same code in the same way. There is optimizations I could have done with that blueprint, but I wanted to show a 1-to-1 ratio to here's what the code actually is saying, and this is how we would write it in blueprint exactly, in that same exact way, to an extent. Again, the big ones, here are the big nodes. Here's the mathematical stuff. So here's 1. Here's 2. Actually, this is going to be sequence 1. Sequence 2. Sequence 3. So just break this down. You do not need to put this in your code. I'm only doing it this way here right now to show you blueprint to C++. And that's the thing that I want you to get drilled in your head, is that the purpose of this course is to teach you the C++ side of it, but it's to be in conjunction with the blueprint as well. There's things you'll write in C++, and there'll be things you'll do in blueprint. And it's not evident where that line is at times. Sometimes you'll do things in blueprint, and then you'll realize I probably should have done that in C++. There'll be things you'll do in C++, and you'll be like, I really should have done some of this in blueprint. All right, so the change here, if we go look at the blueprint class, here's the header, BP Is floating actor and BP. The big thing is they're using T object pointer in here. In the code, it's just going to be a basically it's an object pointer. Cool. We can just use scene component star, which is the the pointer, creating a reference as a pointer. But the big one is they have the mesh and they have a default scene root. And if we can jump back to the code, I've actually built this one up with the default scene root and the visual mesh. In this case, we look at the constructor. I create default scene, it's the object of scene component. I call it the root. And then I attach it as the root component. And then the visual mesh is getting attached to this default scene component, root. Again, that's going to give us, jump back to Unreal. If you look at the viewport, I mean, here's default scene root, here's the mesh. And we go look at, jump in, go back to the lab. So over here is the C++ class. You can see here's the default scene root, named root. Here's the visual mesh, named mesh. And this is how we wanted to set that up in Unreal. The one thing that we had to do here is I needed to offset the location by -50 by 50. Let me put this back at 0. You can see that if I don't do that, you can see that the mesh is oriented on the root. The root is on the corner here. If I go press play, you can see that it's going to rotate around that point. So that's why you see here the -50, -50. So in this case, the second time, I am creating the visual mesh. And I'm setting up the default root, and I'm also giving the relative location automatically -50 by 50. You'll find that this is going to get overridden multiple times. When I add the mesh to the object, this gets sometimes will get overridden back to 0, 0. So when I went back, again, let's go to, so the last one here is the floating actor from the blueprint floating actor from CPP. And we'll go with the visual mesh. I've set it in here, -50. Let me just see. Yeah. So I've set it here as well. So it's one of those you can go in, you can set it in the blueprint class itself. So that's something I had to do to get that to move in the correct way I would want it to be. I had to go in and I actually had to set the cube, and I'm actually going to make, so just to show you what I had to do for that setup, let's go to my content draw. Here's the floating actor. So I'm actually going to right click, create a blueprint class. And I'm just going to call it floating actor 2. The floating actor class. And here we go. Content draw. So in this case, here's the visual mesh. In this case, I had to literally go into the static mesh portion here and tell it, hey, cube. And I think shape cube is the one that we're using. You can see the location is already offset by 0. So let me save this. It's floating actor 2. And you can see right there, oh, it's coming in. It's going to rotate. Display. It's rotating correctly. That's interesting. So when I was working on this earlier, I was getting issues where it was rotating around the point. But here it is. It's just rotating correctly as I want it to be. So that's interesting. So be mindful that you might get a scenario where was I not using I want to go back to the actor 2. Was it shape cube? Was it SM cube? Is that what I was using? Yes. Okay. So in some cases I was using the SM cube. Here is the mesh again. Here's the issue with the mesh. It comes in with ML prototype gray. Again, this is where metal grab, make it steel. So this is the case. So I was using the SM cube, not the shape cube. So this is a cube that has its origin on its corner, as opposed to the other. So that's why I was using the wrong cube asset. So be mindful there are multiple cube assets. But I just showed you if we were to use the SM. Why did I think this was the right asset? Because SM is the old prefix for static meshes. So if you had a static mesh, like if you go back to Unreal Engine 2 and 3, any static mesh had a prefix of, by default, the asset had an SM in front of it. So assets had a prefix. This is something that is legacy to Unreal Engine to 2, to 3, to early 4, which has died out with 5. Something that Epic has kind of said, you don't really need to do this. But you'll see this practice. You'll see like Synthy will do this still. So you'll see packages of static meshes and other things where, again, the idea here is that the SM in front of it is to indicate that this is a static mesh object. This is a variant of what's called Hungarian notation. And Hungarian notation basically comes from Microsoft, and it's called Hungarian notation because the person who developed it, who came up with this idea to do this, was Hungarian. That's all you need to know about the history of where it comes from. But the idea is that variable names, it was particularly for variable names, but Epic took it and applied it to assets. So there's a prefix you add in front of your name of your asset, your variable name, to indicate what type of object, what type of variable it is. You go back further, you see a lot of variable names with B as active, B being Boolean. F being, you'll see F something for that's a float. Sometimes you might see an I for an integer. PTR was the big one. You'll see that pointer, and you might see more PTR. So object pointer. So there'd be PTR OBJ underscore something, or PTR a or PTR actor underscore. So a pointer to an actor is how Hungarian would go. I need to remind you that they were coding without IntelliSense at this time. So this was actually an important way to do things. So this is a little history lesson. When you see things like B in front of a variable name, that's what's going on. When you see SM underscore, that's what's going on. As you create your own things, do you need to do this? No. And Epic is kind of like, don't need to use the prefix anymore, typically. Particularly, the other way that they use this is that they'll use a lot of prefixes for high-level project-specific classes. So, and that's still in effect here. I'll go back and I'll show you that in one moment. Let's actually jump back and show you what I mean. So I created, if we look at the .h, we look at the top right here. Here is CP Dev S26. That's the project name I created. That's the name of the project that I created here. And you can see there's a packet, there's a namespace called CPDev 26 score under API. So all the code is going in that package that you create. So it's a project name underscore API. So if you're taking code from one project, bring it over to another project, that's one thing you need to change. We move on. go look at the so CPP dev S26 is the string that we're looking at. We back to Unity, sorry, to Unreal. So I've got a folder with that name, and you can see I've got folder CPP dev S character, game mode, player controller. Those are the three right here. So there's a character, there's a game mode, there's a player controller. Again, we're using the third person project, so that's why we have specifically, this is, we have the character. So these are all set up specifically for you to do what you want. They're set up to be the default classes for your project. So for Unreal Tournament, that prefix was UT. I could see Rocksteady at some point using Batman as their prefix, or Arkham as their prefix for their projects, or for at some point. So, all right. So the floating actor in this case is setting up in code is setting up a reference to a static mesh, but isn't necessarily setting it up. We're going to take this one step further. We're going to do floating actor. Let's actually create the mesh. Let me compile this so we can move on. Tools, the actor, next, floating. So I'm gonna call it floating actor no mesh. And again, I'm showing you, and this is going to be the way that you would most likely build your objects in this case. So let's create the class. I'm recording right now. Compile the code. There we go. Okay. So let's jump back to C++ classes. Here's no mesh. Okay. Reload all. Okay. All right. So the one thing I am going to keep, in this case, I am going to keep the default scene root. Okay. And then the one thing I'm going to keep out of here is I'm literally just going to set up the scene root, set it as the root component. So that's here's the constructor. So the idea here is I'm not even going to bother adding a static mesh to the object. I'll do that completely completely in my, so the idea here is this, so the goal here is that what I'm doing is being, and actually the one more thing I do need to keep is the code. Let's not use that one. Here we go. Let's grab this code. So jump back and drop that into the tick. So again, same code, done three different classes. Let's jump back and let's compile this now. And why is this working? Because we're working on the actor level. So let's jump now. Well, now that we've got that code, we can jump back to our C+ classes And here it is. Let's create a new blueprint class derived on the floating actor no mesh. We'll do BP underscore. And I really should be putting these in this a lab folder. So I'll put that. I'll deal with that later. Where did it open? Okay, open up here. So again, here is the default root. Again, I'm just going to go add the cube. And it should be right on. There you go. Attach it to the and the cube needs to be moved up. It should be in the right location now. I'll give it a clay material just so we can see the difference. All right, jump in. And here it is. And I think I've got it all set up correctly. I'll move this over here. Press play, you can see that. Hey, now it's doing what we expected it to be doing. Again, the one problem I've got with what we're doing right now is that all these cubes are going below the floor. That's a so let's wait to put this. It's a problem of the delta. The height can be a negative. We start with its starting location, the actor location. So ultimately, that's I should be doing a starting location plus the change in the height, making sure it's so the way that we're using the sine. This is because we're using the sine function. If I was doing this differently, I could use an absolute value to make sure it's not. So when it goes a negative, it's going positive back up again. So it'll bob faster effectively. But this third way is what you are most likely going to be doing. You'll be doing a lot of as much as you can in the C++ class, and then assigning meshes and things that you would actually be using in the blueprint side. You'll create variables. One of the big things that they're doing. Let's take a look at. Where is it? Here's the third person, and here is the blueprints. So there's a BP third person blueprint, game mode, and third person controller. So they've inherited all these classes. Look at the game mode. They're using the BP versions of that. So even still, like they might write stuff in there's code that they might write in their game mode. They're still inheriting that game mode, that C++ game mode class to a blueprint. Same thing with the player controller. Same thing with the character. Close. Go back. We can look at the character. Now they are doing a lot in the C++ side on this one. But there is, again, they're setting a lot. Yeah, there's a lot being set up in the C++ side. But there's still, again, we've got event. They're not writing as much code. Here is event possessed. Is it the player controller, branch? So they're still doing some things in here. There's the do look, do move, do jump start, do jump end. If you look here, those are all functions defined. Let's jump into, here's the character.cpp. Here is set up player component. move, do look, do jump start, do jump end. So they're calling those functions are literally written here. We go look at the .h. Look at the, here is, again, U function. And this is something we'll see. This is something we'll look for. Again, here's do move, do look, do jump start, do jump end. They've got blueprint callable signed to them. We'll take a look at U functions next week, and how you set up the U function, how it's set up here in C++ will determine how you will use it in Blueprint. We didn't really talk much about Blueprint pure functions. We'll talk about them next week because we have to. But we'll what is a Blueprint pure function versus one? Yeah, we'll deal with that next week because you'll have an assignment where you have to write each version so you can see what's going on, and then call them in. Literally call them in your Blueprint class. You'll have a C++ class, and you'll inherit it into its child Blueprint, and then use the C++ code in the Blueprint side. So make sure I save everything. So again, here is again. Push this out here. I mean, this is. Grab these three. So again, here is basically what here is the Blueprint class, what you've been used to. Old school, somewhat more new school. And then finally, what Epic is actually doing. So there are times and places where you need to do this setup. There's time and places where you don't, and this is perfectly fine. This is the old school method. So I've shown you 3 different ways. Do for your assignment, follow the assignment. Follow the tutorial as shown first. But come back and do it again. Make another class where you inherit, 2 classes, the C++ and the Blueprint, where basically you inherit from it. And you set up the object in the Blueprint class, did what you want. I will assign extra credit to set this second method where you create the mesh reference in code and assign the object in a Blueprint or the instance. In fact, this one right here is I've gone into the instance of the object to set up the variables. Not necessarily wanting to be doing over and over. That's why you make a Blueprint class, so you can set those and use over and over again. I've gone through this and I've pulled it apart piece by piece by piece by piece by piece by piece. Have I lost anyone with what I've gone over? Okay. All right. I'm going to stop the recording here, upload it to YouTube, and then, and meanwhile, jump in, start playing with code. If you hadn't finished Lab 1, now's the time to do it. I know some of you have submitted, but basically submit your .h and CP file for the class you created, the output example. That's what I need for Lab 1. I cannot take your Unreal project because it's huge. It's like 1G on disk already. Yeah, Unreal is beefy on disk as a starting project. And then on top of that, the starting content. Yeah. And you wonder why why some of the games are choking right now, because they're not optimized.